If you haven't answered this first question, I want you to go on and start to do that on your own and try to work through this packet as much as you can on your own before taking a look at the video. So here when we're talking about slope, we can depict it with a lowercase m, and normally we think of slope as just being our rise over our run, or our change in y over our change in x, or we could go to looking at the algebraic formula, which is y2 minus y1 over x2 minus x1. So now let's talk about slope when we're talking about parallel lines. So we will learn quite a few formulas, or excuse me, quite a few theorems this year in geometry, and this is our first one. This tells us that we have two non-vertical lines. They are going to be parallel if and only if their slopes are equal. So let's take a look. We've got two lines here, and they appear to be parallel, but you'll learn that we can't assume in geometry. So we've got to prove this. So if I'm going to label each of these points, I'm going to call that top line line A and the bottom one line B. So let's calculate what our slope is of that line A. So I'm going to take my difference in my y values. So I'm going to do 6 minus 1 over the difference in my x values, which is 2 minus 10. And that just gives me 5 over negative 8 for my slope. Now, if I look at the slope of the other line, I'm going to do the difference in my y values. So I've got 2 minus a minus 3 over the difference in my x values, which is minus 2 minus 6. So in the numerator, it gives me 2 plus 3, which is 5. And then in the denominator, when I combine those together, I get minus 8. And so we notice here that these two lines have the exact same slope, and so we know those lines are parallel. So now let's take a look at perpendicular lines. And what our theorem tells us here is that two non-vertical lines are going to be perpendicular. Again, we have these words, if and only if. The product of their slopes is negative 1. So let's think about this. If you have a slope that is 2/3 and you had a perpendicular slope, let's say that it's going to be negative 3/2, do you see if we multiply these across, the product is just going to give us negative 1. Okay, so these would be slopes of two perpendicular lines. Now let's take a look at this example that we've been shown here. Let's call this line L, and I'll call this one J. So if I'm looking at the slope of line L, I'm going to take my difference in my y values, so 6 minus 1 over 2 minus 10. Well, this is the same line we had before, and so our slope is 5 over negative 8. Now I'll look at that red line. This is the slope. I've called that line J. And so if I take my difference in my y's, I have 7 minus a minus 1 over 8 minus 3. Well, 7 minus a minus 1 is 7 plus 1, which gives me 8 over 5. So now you look at these, and based on this theorem, is the product of these two slopes negative 1? And let's look. If you have 5 over negative 8 times 8 over 5, if we look at that, we could reduce before multiplying, and it does, in fact, equal negative 1. Another way that you could also say this is you could also say that perpendicular slopes are the negative reciprocal of each other. Negative reciprocal of each other. That's just another way of saying the same thing. Because if two slopes are the negative reciprocal of each other, then their product is going to be negative 1. So now I have just some few problems for you to work out. First, I've given you 2 points, and I ask you to find the slope of every line that is parallel to that line between those 2 points and perpendicular. So why don't you work that out and then come back and check your answer. So now when we plug this into our slope formula, we can find the slope between those 2 points S and T. And I hope you reduced your fraction here so that your slope here is negative 1 over 2. And so any line that's parallel to that line ST is going to have a slope also of negative 1 over 2. But any line that's perpendicular, remember it's going to be the negative reciprocal, that perpendicular slope is going to be positive 2. So what I do want to talk about here is 3 forms of linear equations. You've seen these before. This shouldn't be anything new to you. But standard form of an equation, it just looks pretty. It's ax plus by equals c. And when you're writing an equation in standard form, what is required here is that a must be a positive integer, which means no fractions. Integer means no fractions. No fractions. And it also means A has to be positive, and B and C also have to be integers, which again, integers just means no fractions. And standard form, again, just looks pretty. Slope-intercept form, which is the one people are most familiar with, that's just going to be y equals mx plus b, where we've already said m is our slope. And here, our lowercase b is just going to be our y-intercept. And then finally, we have point-slope form, which is y minus y1 equals the slope times x minus x1. We know m is just going to be the slope of our line, and then any point on the line, doesn't have to be your y-intercept, any point on your line we have noted as x1 comma y1 in this equation. So now these next 8 problems are really just some problems for you to practice these concepts, and then why don't you work on these and then come back and see if you can come back and check your answers. And for some reason, some of the problems have disappeared. I will have these ready for you. So part of trying to figure out the equation for these lines is to determine what you've been given and which form of the equation you want to use. Typically, you're going to want to use either slope-intercept form to get started or point-slope form. So in this first one right here, they actually give us our y-intercept and they give us the slope, so it's easier to put this into slope-intercept form. Our y-intercept is 4, our slope is negative 5 over 3, so we just literally dump that into the equation. Our equation of the line is going to be y equals negative 5 thirds x, and then plus our y-intercept, which is 4. Now, in this next one, they try to trick you a little bit. They tell us our x-intercept is negative 6, and they tell us our y-intercept is 3. Well, this right here, we could plug into slope-intercept form because we know the y-intercept, but this x-intercept right here is actually a point. If our x-intercept is negative 6, that means the point is actually negative 6 comma 0. So if we have the slope and a point, really the easiest equation to use is our point-slope form, which is y minus y1 equals our slope times x minus x1. So if we take what we've been given and dump it into this equation, we're going to have y minus y1, which in this case is just 0, because this is our x1 comma y1. And then our slope is going to be 3, and then we have x minus a minus 6, so just x plus 6. So then if we just distribute the 3, we have y equals 3x plus 18. And there's our equation of the line. Now if we look at this next one, it tells us the line goes through that point 1 comma 2. So there's our x1 comma y1. And it says it's parallel to this line. So if we have a parallel line, we know it has the same slope as this line right here. So if we look at this line right here, we see that the slope is 3. So since we know they have the same slope, then our slope of the line we're trying to find also has 3. So we know we have the bit of data. We know our slope is 3. We have the point 1 comma 2, and we can plug that into point-slope form. So we have y minus y1, which is just 2 in this case, equals our slope times x minus x1. And x1 in this case is just 1. And sometimes you can leave your answer like this in point slope form, or sometimes they want you to distribute that 3 and combine like terms to get it in slope intercept form. So here, if we did that, we could distribute our 3 and then just add 2 to both sides. And so we get y equals 3x minus 1. Either one of these answers are acceptable here. Just depends what it's asking for in the form that it wants. So why don't you want to work through the rest of these and then check back for the answers. So now you can take a look at the answers for the next few problems here. A couple of things that I do want to point out. When we get to these equations that say, or problems that say, find the equation of the line through a point and parallel to another line or perpendicular to the other line, the only thing that we really care about in these other lines is their slope. So you want to find the slope first, and then if it's a parallel line, you know they have the same slope, or if they're perpendicular lines, then you know that the slope's going to be a negative reciprocal. Now in number 5, you had to find your slope first before you could then write an equation of the line. And in number 6 and number 7, you had to rearrange the other equations to find the slope first. And then if it was parallel, you know it's going to have the same slope, or if it's perpendicular, you know the slope's going to be a negative reciprocal there.